Hey guys, welcome to this very basic tutorial on SQL. Today we're going to talk about what is SQL and what are relational databases, why are they useful, and how can we query them. So we're going to look at a few examples, and I'm going to try to go as slow as possible, just give you very few examples so that you can understand the basics really. So here on the left we have a DB schema tool, which is simply used to design our database models. So we design the tables, the relations between each table, just to help us understand what is happening whenever we get lost. It's very useful when you have big projects, and it's always recommended. This is where you start really when you start building a project. On the right we have a DB browser for SQLite. So that's simply a viewer to help us make the queries to the database and view the results. So I'll put the link to the DB browser for SQLite in my bio. Cool. So let's go ahead and start. But first let's talk about very quickly what is SQL. So SQL is a structured query language, and it's a simple programming language that's used to manage relational databases and perform various operations on the data themselves. So how is data structured inside of a database? It's very simple actually. So here we can see in our schema that there is no data actually. The schema design tool is only to view the structure, the skeleton of the database. So we can see that we have a table of artists, right? Each artist is going to have an ID and a name. And then we will fill up this database. So if I go in my browser, I can see that I already have one. I filled it up a little bit. And we can see that I have 275 rows, right? But only 2 columns. So this is how tables work. You have columns and rows. The rows stand for the data, the content that it holds, and the columns are simply the name that you give to each one of these. This is how you identify them. So databases by default, they have something that we call auto-incrementation on IDs. So the ID always starts at 1, and whenever you add more rows, they keep incrementing. Why do we have IDs? IDs are unique identifiers so that you can access a certain row inside of your database, inside of your table, and be able to modify it or read it or delete it. So IDs are always a unique identifier, but often you will find some platforms that use other unique identifiers. It can be a username where people can only use usernames that are not already taken. For example, GitHub uses username as a unique identifier. You can check the URL and you'll see that at the end of the URL they identify you by your username and not by your ID. It works the same way. So let's go ahead and make our first query on our artist table. So the most common query is to read, right? So we want to get back everything that is inside of our artist table, and from there we can keep going on. So the keyword for this is select from, and here we will specify the table, and this is where your column goes, the column name. But a keyword, a symbol for selecting everything in SQL is the little star. By putting the little star, you say that you want to select everything from the artist table. So we can try this, and you can see that we will get back 275 rows from our query. So this is our first query, and it's a lot of content. So let's look a bit later on how to get more specific data. But first, let me introduce you to another short keyword, which is where. Where is a keyword to give a condition. So for instance, I could say that I want all the artists that have an ID 90 or bigger. Or if I want one specific data, one specific row, I can say give me back the row which has an ID of 4, for example, or the name of Alanis Morissette. So again, we just write the keyword and we give the condition. So where the ID is equal to 4. And we get back Alanis Morissette. You can do the same thing with name, equal to Alanis Morissette. And we will get back the same result, just based on a different condition. It's going to be useful when you want to browse through your database, when you want to read something that is similar to this, but we will get this near the end because it's not the most important right now. The next thing we want to do is we would like to add something inside of our database, right? We want to insert a new row. So the syntax for this is insert into. We give the table name. So in that case, again, it's artists. And then in parentheses, you give the columns you want. So here we will give the columns. And then you tell what values you want inside of these columns. So for instance, let's do 1. The table here in this case, the name, the column is name, right? The ID we don't need to specify it because, as I said before, it's auto incremented by the database. So whatever the last row is, this one is going to be +1. So we only need to specify the name column, and we say what do we want this name column, this name row to contain. So let's insert Michael Jackson inside of it. You can execute it. Query executed successfully, but we want to see it. So let's go browse and go at the very end, and you can see that Michael Jackson has now an ID of 276, which is one more than the previous one, and has a name. So this is it for inserting. Obviously if your database has more columns, you can specify the other columns. If you don't, it will have a default value of null, which stands for nothing in SQL. Is empty. So next query is the update method. So let's say that we want to update our Michael Jackson name. You simply say update, and again you give the table name. You want to tell it where you update, and we will give it the new value. So in that case we will say that the name is equal to test. However, be very careful because here you still need to give a condition, right? Because it doesn't know which row are you trying to update. We know that we want to update Michael Jackson, but the database doesn't know it. SQL doesn't know it. You have to specify it. So you say where, and you can say, for example, the name is equal to Michael Jackson, or since we know the ID, we can simply say where the ID is equal to 276. Query executed successfully. Let's browse. And Michael Jackson is now called test. And finally, the last query that I want to show you to respect our CRUD for create, update, create, read, update, and delete is the delete. So what if we want to delete Michael Jackson now? Or test, actually, because we changed the name. So you simply say delete from. Again, you give the table name. So we want to delete from artists. And one more time, be very careful, because if you do not give a condition here, it's simply going to delete everything that is inside of your table, and your table is going to be empty because it doesn't know that you want it to delete a specific row. So where the ID is equal to 276, executed successfully, and Michael Jackson or test is now gone. We are back to 275 IDs. That's great. So now we have the basic queries, but I want to show you something else. So if we have a look at another one of our tables, so the albums, you can see that we have the ID, which is the unique identifier. We have a title for each album, but then we have this other column called artist ID. And this is not a unique identifier because we can see that it can have several times the same value. So this is what we call a foreign key in relational databases, right? So we are basically saying that this album is connected to the artist ID with this current ID. So in that case, it's 2. So if we look at the artist table, it's the artist except. So you can see here that in the schema, I connected them by links so that we can understand a little bit better. What is happening exactly if we put it in real world? We are basically, let's take Michael Jackson again as an example and look at him in his career, let's say. Michael Jackson has many albums, right? But each one of these albums, they belong to Michael Jackson, right? The albums that were made by Michael Jackson, they cannot belong to Madonna. They are specific to him. But him, Michael Jackson, can have more than one album. Whenever he feels creative, he makes a new one, or used to make a new one. So this is what we call a foreign key. We connect them by giving a new column to the albums. So to the one that belongs to, we give it a foreign key, and we assign it the value of the ID of the one of the parent, right? You have to see this album's table as a child, and the artist is the parent. So in the child table, you put the artist ID as a column, and inside of the row, you assign it the ID of the parent. It might be confusing right now, but we are going to go through an example, and you will understand it better. So let's go ahead and execute some SQL on our albums table. So select everything from albums. And we get all the rows, 347. That's great. But we can't really see the names, right? We only see IDs. So we want to know what's behind these IDs. And we can do this because we have the foreign key connected, right? So thanks to SQL, we can use a keyword called join. And join works in a very simple way. It's very similar to English, really. So we are going to say that we want to join the artists. So we want to join the artists table on, and here it gets a little bit more confusing. So we want to join the artists table on the albums dot, so we are referring to the table name, albums dot artist ID equal to artists dot ID. What is happening? Let me go through it one more time. So we are joining to this table here. We are joining to it another table called artists. But on what condition? On the condition that the album's foreign key, so that this key here is equal to the unique identifier of this guy. So we are going to join to this table all of the artists that have the same ID as here. So here we will assign the artist with the ID of 4, here the ID of 5, here 3, here 1, etc. So let's see what happens. And this is exactly what we expected, right? So here we get the artists with the ID of 1 because the foreign key was 1. here 4 because the foreign key was 4, etc., etc. And we can access their names now. So this is what's awesome. We don't have to access their IDs. We can access them by the name. So for example, if I wanted to be a bit more specific on my query and only get the artists called, for example, if I say where name is equal to, I forget the quote marks, Iron Maiden, I will only get the specific rows for this artist, and I get his name, so I can see more things. If this artist had tracks, had albums. I'm not going to go into the tracks in this tutorial, but you get the idea. So this is great. We just made our first join query with our foreign keys. Now let me show you another thing, which is basically, so here if I write iron with a lowercase, for example, or if I write just iron, I would want to be able to still see the same result, right? But SQL won't give me the same result. So this is where another keyword comes in place called like. These are optionals, really. I'm giving you, it's a bit more advanced. You can read more about them. So the keyword like works very simple. So it goes inside of the condition. So we say where name, we add the keyword like, you say is equal to, and here we are going to add a wildcard represented by a percentage sign. So if I put iron here, I am still not getting anything. Sorry. So where the name is like iron. Why am I not getting anything? Because by putting the percentage, the wildcard, at the beginning of our quote marks, it's looking if there is any row that ends with iron. So if I remove it and I put it at the end, we are saying that we want all the rows that start with iron and can have more content afterwards. So there we go. We can see that we got back 21 rows and they all have the word iron inside of their name. So what if we only want 10 rows, right? So there is a query for this, there is a keyword for this as well, but first I want to show you how we can get more wild with the wildcards. So let's say I want to get back all the names that have the letter AR in them, but I want the letter AR to be anywhere. It doesn't have to be at the beginning, it doesn't have to be at the end, it can be anywhere. So you simply surround this pattern with the wildcards. And I'm not sure what's happening. Syntax error. So where name is like alright, so the like keyword has to be, I'm not sure what happened. So we want to get back everything where the name has AR inside of it, and we can see that we obviously get many more rows, Aaron, Richard, because they all contain AR inside of them. So what if we want to order these, let's say we want to order them, right? So we can say that we want to order them by the name or by the ID. And you will see that it is ordered by ID. So you check here. And it keeps going. But what if we want the last ones first? Because by default SQL is giving us an ascending order. So we simply specify that we want it descending. And there we go. We get the last ones first. You can do the same thing with the name. So alphabetically ordered, and we will get the last names, because we're specifying the name, not the title anymore. So we're getting the last names first, based on this condition, of course. We have 69 rows, so maybe we just want to limit this. We want to get the last 10 artists that have AR inside of their name. So you simply say limit to 10, and we will get the 10 last ones. And there we go. So remember, the foreign key is always inside of the child, and as a value has the ID of the parents. So feel free to leave a like and subscribe, and please comment below if I can maybe help you with anything else, maybe make a next video about SQL, maybe more advanced. Obviously this is very basic and it's just an introduction. So thank you so much for watching, and comment, like and subscribe. Peace.